Let me work out in this video an example of how to work out echelon forms in matrices. So let's consider the following matrix. Let's look at the matrix 1, -1, 2, 3, 1, 2, -3, 1, -2, 0, -1, 1, 1, 0, -1. And suppose that we want to find the reduced echelon form for this matrix. In here, what we want to do is we want to achieve the echelon form similarly to the system of equations form, but with the matrix. In this case, we don't need to worry about the variables x, y, z, w, or whatever variables we have, and we can focus only to the matrix relations in here. So what we're going to do is we're going to start clearing out the coefficients one by one. So for example, we can see that in the first row, we have a 1 already over here. So that means that this will become our first pivot for this matrix. This means that we have to get rid of these two coefficients. In other words, what we want to do is we want to use that fact that this one on the top, the first component, is already good for my echelon form, and I want to get rid of the variables or the numbers that are below it. So what we can do is we can actually take the first row, the second row, and the third row and start doing operations with it. Let me use R1, R2, and R3 to denote the rows, so I actually know which row in particular I'm talking about. And what I'm going to do is the following thing. My first move is going to be to get rid of these two right here. And in order to do that, I'm going to exchange the second row by, we can do second row minus 2 times row 1. By doing that, I'll definitely be getting rid of that 2 over there. So the row that I'll be substituting will be, I think I can just write down the row over here. That will be R2, which is 2 minus 2 times 1. Let me write it down that way. Then I would have -3 minus 2 times -1. Then I'll have 1 minus 2 times 2. Then I'll get -2 minus 2 times 3. And then finally, I will get 0 minus 2 times 1. So this is the result of computing the second row minus 2 times the first row. In other words, what I'm computing over here would be 0. That would be the first component of that row that I'm going to substitute. Then I have -3 minus 2 times -1. So let's see, that would give me, I believe that will give me -1. Then I will get 1 minus 2 times 2. That will give me -3. Then I'll have -2 minus 2 times 3. That would give me 2 minus 6, which is -8. And then I'll have 0 minus 2 times 1. That will give me -2. Please check that I have the right numbers over there. So I will exchange the second row in my matrix by this new computed row that I have. So that means that my new matrix is going to be, first row is going to stay the same, which is 1, -1, 2, 3, 1. That's the first row. And then my second row is going to be this row that I just computed, which is 0, -1, -3, -8, and -2. Finally, the third row is going to be the same one as before, which will be -1, 1, 1, 0, and -1. So notice that I'm achieving the pivots in here, because now I have that the second pivot is going to be to the right of the first pivot. Whenever we're computing echelon forms in matrices, we actually need the pivots to be actually the number 1. All of the pivots have to be the number 1. So my last move in order to convert the second row into echelon form would be actually to divide this new, or to multiply this new second row by -1. Either way will make this pivot to become a 1, a positive 1. So we're going to exchange the second row with minus the second row. So this will give me then first row to be the same, 1, -1, 2, 3, 1. Second row will become 0, 1, 3, 8, and +2. And then the last row remains the same for the moment. So again, what we have in here is that we're getting closer to our echelon form because our 2 pivots so far are working fine. Now what we can do is we can try to get rid of this -1 in the last part of the row and this +1 that we have over here. So we can try to do that. Maybe we can do this in just one move, because if we replace the third row by the third row plus the first row, that will definitely get rid of this part right here. And then what we want to do is to get rid of the result for this. So let's try to do the first step and see what happens. That means that what we want to do is we want to exchange the row number 3 by the sum of rows 1 and 3. So let me first compute the sum of rows 1 and 3 and see what that is. If we do that, that should be 1 minus 1, minus 1 plus 1, 2 plus 1, 3 plus 0, 1 minus 1. So we're adding the components of rows 3 and 1. And this just gives me 0, 0, 3, 3, and 0. So that will be the computed row in here, which means that I can go back to my original, this expression, and I can just replace the third row by the one that I just computed. So that means that the first 2 rows will remain the same. That would be 1, -1, 2, and 3. The second row is 0, 1, 3, 8, and 2. And then my last row would be the one that I just computed, which will be 0, 0, 3, 3, and 0. So now we have that the 3 is in my pivot position. This 1 is in the pivot position, and this 1 is in the pivot position. So I'm achieving that echelon form so far. But remember that whenever we're talking about matrices, we need our pivots to be equal to 1, which means we need to convert this number 3 into a 1. And we can achieve that by replacing the third row by 1/3 of it. If I multiply by 1/3, that means that I will be able to get rid of that 3 over there, which means that my echelon form will be 1, -1, 2, 3, 1, 0, 1, 3, 8, 2, 0, 0, 1, 1, 0. So again, notice that all my pivots are actually equal to 1. And I again have this echelon form as before. So the important part about the echelon form is that it has to have zeros underneath the staircase. If that's true, then I already have my echelon form. So in this part, we have that this is already the echelon form. Or rather, I would say an echelon form. Because we have that echelon forms are not unique. There could be many echelon forms. But what is unique is a reduced echelon form. So in order to complete this problem, I need a reduced echelon form. And a reduced echelon form not only cares about the actual pivots, but also it cares about the other numbers in each pivot column. In other words, what I'm requiring is that every other number in this pivot columns has to be 0. The only numbers that can be non-zero are the pivots. Actually, the pivots are going to be 1, and the non-pivots are going to be 0. So these are the conditions for a reduced echelon form. The only thing that I have to do now is to actually get rid of these other numbers. I have to get rid of this one, and this one. I have to convert those numbers into zeros. And we can do that by just using the pivots themselves. That's the reason why we need our pivots to be equal to 1, because that will easily help me to actually get rid of the other non-zero numbers. So for example, let me just start with this -1 over here. So you can probably agree with me that if I replace the first row by the first row plus the second row, I will get rid of that -1 over there. In other words, let me compute the sum of the first two rows. That will give me 1, 0, 5, 11, and 3. If I add the first two rows, I'll get 1 plus 0, -1 plus 1, 2 plus 3, 3 plus 8, and 1 plus 2. So my new updated echelon form, this is not yet a reduced echelon form, will be this to be my first row. My second and third rows are going to remain the same. So this will be 0, 1, 3, 8, and then 2. And then the last row is just 0, 0, 1, 1, 0. So again, my updated echelon form in here is looking better because the first two columns actually already satisfy the requirement of a reduced echelon form, which means I'm only allowed to have ones in the pivots and zeros everywhere else. Now the only thing that I have to do is I have to take care of this third column. I have to get rid of this 5 and this 3. So what I'm going to do is I'm going to replace the first and the second row by the following. Let me try to do this at once. So I want to replace the first row by the first row minus 5 times the third row. So again, notice how having this 1 down here is very convenient because I just have to multiply by the number I want to get rid and subtract to it, and that will help. Likewise, for row number 2, I have that I can replace it by row number 2 minus 3 times row number 3. Again, this coefficient in here is literally the number that I want to get rid of. And that is the advantage of having this pivot being equal to 1. It's literally just clearing the way from me. So that means that, let's see if we can do this. We have our first row. Our first row is going to be the first row minus 5 times the third row. So that will be 1 minus 5 times 0, 0 minus 5 times 0, 5 minus 5 times 1, 11 minus 5 times 1, and 3 minus 5 times 0. So that will be my new row 1, is this part right here. Second row is going to be similar. It's going to be the second row minus 3 times the third row, which will be 0 minus 3 times 0, 1 minus 3 times 0, 3 minus 3 times 1, 8 minus 3 times 1, and 2 minus 3 times 0. So we have that's the second row. And then the last row, we're just going to copy. We don't do anything to that one. Now this is the reduced echelon form. And I say the because there is only one reduced echelon form for every single matrix. If you try to work this one out yourself, you might achieve different echelon forms. For example, the path that I took over here to arrive to this expression is not the only thing that you can do. You can do multiple things. And depending what you do, you might arrive to different numbers. You still will have the same pivots in the same places, but the other numbers, the rest of the numbers, might be different. That's why we say that there could be many echelon forms in your matrix, but there's only one reduced echelon form. No matter what you do, you will have that this is the final version of your echelon form.